Created a Blender file where you can actually test the Dzhanibekov effect. You see how this object spins and it looks quite stable, and then all of a sudden it flips over. Just like so. Well, this Russian cosmonaut discovered this in 1985, and it's pretty cool. And it's also known as a tennis racket theorem. And you can find that on Wikipedia, and I'll give you a link for that. But I've also created this Blender file that lets you just try this out for yourself. So if I open up Blender here, I want to show you the important bits of it. So because you can, I'm going to give you a link to this, and you can download it from GitHub. The important bits is that when you start it, there are multiple ways of starting it, like such as P. I'm in the Blender game engine. P starts it up, and then if I press S, just tap S, it starts it off, and then it will flip after a second. This object I have selected as a its physics properties are damping, translation 0, rotation 0, the Z-axis is locked, and the collision bounds is ticked, and it's a triangle mesh. The other important properties are in the logic editor here. I've created a key for S, and when you click S, it changes the force. It's a simple motion force, the torque on the Z-axis being 100. And to create that condition where one of the axes is slightly offset, I've put 0.01 here in the X. What that does, if I press play again, and I tap S, it just applies a little bit of torque, and enough torque on X to cause it to destabilize after a moment of time. That's because in game engines, physics is perfect. Well, not really, it almost is. So if I set that X to 0 and press play again and press S, that will just spin forever. Even if I hold down S and just keep applying torque. Oh. So in order to cause that Dzhanibekov effect, I just have to add a little bit, something a little bit there. I'm going to add 001 this time, so it happens. P, S. There we go. It's flipped over. I'm going to apply lots of torque now. Whoa, now it goes nuts. And it kind of stabilizes a bit like a banana. Let's just keep applying it. And keep applying torque. Yep. It's a lot of torque on the Z-axis and a little bit on the X. Thanks for watching. Like, comment and subscribe, and you can download that Blender file and experiment with that as much as you want, and share it because it's Creative Commons attribution for you. Thanks. See you later.